Welcome to The Explainer. Today, we're tracking the biological journey of a substance so incredibly common, I'm willing to bet you probably consumed it within the very first hour of waking up today. Yep, we're talking about the world's most widely consumed psychoactive drug, caffeine. We're going to map out exactly what happens inside your body and your brain from the exact second you take that first sip right down to the cellular level.
Just to wrap our heads around the sheer scale of this habit, in the year 2020 alone, nearly 10 million tons of coffee beans were consumed globally. I mean, that is an astronomical figure, right? It crosses all borders, all cultures. It's really not just a beverage. It's a fundamental part of how human beings function.
So, the real question we've got to ask ourselves is, how much of that 10 million tons is driving your day right now? Because whether it's coffee, tea, or a glowing energy drink, you are participating in a massive daily biological experiment. Let's unpack exactly what that experiment is doing to you.
Chapter 1. The world's favorite drug. You know what's really fascinating about caffeine? It's a naturally occurring alkaloid found in the leaves, seeds, and fruits of several plants. But unlike almost every other psychoactive substance on Earth, it remains largely unregulated and completely legal almost everywhere. And here's a big reason why it's so remarkably effective. When you consume caffeine, your body literally does not waste it. It has a 99% bioavailability. That means practically every single milligram you ingest successfully crosses into your bloodstream and makes its way into your system. It is just an incredibly efficient delivery system.
Moving on to Chapter 2, Hacking the Brain's Receptors.
All right, so what actually happens once it gets into your bloodstream? Well, to understand that famous caffeine buzz, we have to travel up into the central nervous system and look at a completely different molecule. It's called adenosine. Think of adenosine as your brain's natural brake pedal. From the very moment you wake up, this stuff starts accumulating in your synapses. The longer you stay awake, the more adenosine binds to its receptors, essentially telling your brain to slow down and promoting that feeling of drowsiness.
Now here's where the hat comes in. Caffeine happens to have a 3D physical structure that is incredibly similar to adenosine. Because of this sneaky resemblance, caffeine acts as an antagonist. It fits perfectly into those exact same receptors in your brain, but instead of activating them, it just sits there, completely blocking the actual adenosine from getting in. So if adenosine is the brake pedal, caffeine is like a wooden block wedged firmly right underneath that pedal. It's not actually pressing the gas, it's just stopping your brain from hitting the brakes.
Chapter 3. Performance and Medical Perks. By removing those biological brakes, we unlock a whole host of effects and some very tangible, proven benefits in the real world. In moderate doses, caffeine acts as a proven ergogenic aid. Physically, it delays both central and muscle fatigue, and it boosts aerobic endurance, which is exactly why so many athletes absolutely rely on it. Cognitively speaking, acute intake actually improves your reaction time and your accuracy. It even has a proven synergistic effect when combined with L-theanine, which is an amino acid found in tea, to significantly promote alertness and your ability to switch between tasks.
But beyond just getting us through a workday or a tough workout, caffeine actually has profound medical utility. Caffeine citrate is literally on the World Health Organization's model list of essential medicines. It's used as a primary treatment for premature infants who suffer from breathing disorders, like apnea of prematurity. Because it stimulates the medullary respiratory centers in the brain, it actually helps remind these tiny infants to keep breathing. Pretty amazing, right?
Which brings us to Chapter 4, Interactions and Daily Limits.
But, like any powerful compound, what goes in must eventually be processed and come out. Your liver is the real hero of this pharmacokinetic journey, specifically an enzyme called CYP1A2 that does the heavy lifting. It basically strips a methyl group off the caffeine molecule, breaking it down into 3 distinct metabolites: paraxanthine, theobromine, and theophylline. And what's wild is that each of these actually has its own minor effects on the body before finally being excreted in your urine. What makes this liver processing so fascinating is how our everyday habits alter it. For instance, smoking tobacco actively induces that CYP1A2 enzyme. That means it processes caffeine faster, increasing clearance by a massive 56%. This is why smokers often end up drinking way more coffee just to get that same buzz. On the flip side, taking birth control pills actually slows that enzyme down, extending the half-life of caffeine by up to 40%, meaning that innocent afternoon coffee is going to stay in your system much, much longer.
Because these effects can linger, medical bodies have established some pretty clear benchmarks for us. Health Canada, for example, sets the scientifically backed daily limit for healthy adults at 400 milligrams. To put that in perspective, that's roughly 3 to 4 average cups of coffee. Now, there's a drastic drop in that safe threshold for adolescents and children, obviously, because their bodies and brains are much smaller and way more sensitive. For young kids, just 45 milligrams, which is roughly 1 caffeinated soft drink, is the recommended daily maximum.
Chapter 5. The Dark Side of Caffeine. This naturally leads us to a big question. What actually happens when we ignore those limits? Because while it's totally safe in moderation, we have to remember it is still a potent central nervous system stimulant. When you cross the line from a few hundred milligrams into the 1 to 1.5 grams territory, so about 1,000 to 1,500 milligrams, you enter the realm of a condition medically known as caffeineism. At this threshold, caffeine completely stops being a performance enhancer and becomes a significant source of physical and mental distress.
The symptoms of this level of intoxication are severe. By excessively blocking those adenosine receptors we talked about earlier, your central nervous system becomes dangerously overstimulated. This results in severe anxiety, total insomnia, tachycardia, which is basically a racing heart and palpitations, major gastrointestinal distress, and in highly extreme cases, a muscle breakdown condition known as rhabdomyolysis. It's essentially your body's alarm system going haywire because the biological brakes have been entirely ripped out.
And yes, there actually is a lethal limit. The fatal dose for an average adult is estimated at around 10.5 to 14 grams. Now, realistically, you would have to drink roughly 75 to 100 cups of regular coffee to reach that, which is practically impossible for most people to physically stomach. However, the real specific modern danger here is pure, concentrated caffeine powder sold as dietary supplements. Because it's so incredibly dense, a lethal dose can easily be consumed in just a single tablespoon-sized amount. Definitely something to be careful with.
Finally, let's look at the tolerance trap.
Thankfully, extreme overdoses are super rare, but there is a much more common biological consequence to daily use that we all face. I want to leave you with this provocative question, based on what researchers call the withdrawal reversal hypothesis. See, when you consume caffeine every single day, your brain realizes its adenosine receptors are constantly being blocked, so it adapts. It literally grows more adenosine receptors to compensate. This means you need more caffeine just to get the exact same effect. When you wake up in the morning, your brain is flooded with adenosine hitting all those extra receptors, causing that heavy fatigue and a foggy head. So is your morning cup actually giving you a net positive boost above your normal baseline, or is it simply reversing the mild withdrawal you built up overnight just to get you back to zero? It's a fascinating biological reality to ponder the next time you pour yourself a cup. Thanks for joining me on this explainer, and keep questioning the science behind your everyday life.